example, a bulk fuel storage cylinder 5 metres in diameter and 8.5 metres high, made of steel, is 90% filled with aircraft fuel at a temperature of 18 degrees C. If the storage cylinder is involved in a fire and heated to 415 degrees C, how much fuel will be forced out? And it tells you the coefficient of linear expansion of steel is 3.75 times 10 to the minus 6, and the coefficient of cubical expansion of aircraft fuel is 950 times 10 to the minus 6. Now, how do you carry out this calculation? Well, this question involves expansion, and if you draw out the problem, this is what you're going to find here. What we have to determine is what the original volume of the cylinder and by how much it expands compared to the expansion of the fuel. So what is the volume of the cylinder? Well, the volume of the cylinder here, shows you here, is pi r squared times the height. Substitute in known values, you get 166.9 metres cubed. So that is the volume of that particular thing. Now, the fuel only occupies 95% of the cylinder, so 95% of that is 158.56 metres cubed. Okay, so you know now the volume of the fuel. Now, let's determine by how much the cylinder will expand and by how much the fuel will expand. That's what you've got to do, haven't you? You've got to work out now by how much the cylinder expands and how much the fuel expand. Now, firstly, let's determine the final volume of the cylinder itself. Now, the expansion equals the linear coefficient times 3, don't forget it's cubical expansion, times the temperature rise times the original volume. Well, the expansion is, if you put these known variables in, you know these variables, you get the expansion at 0.745 metres cubed. So that is the expansion of the container, 0.745 metres cubed. So the final volume of the cylinder is 166.9 plus that 0.7 is 167.65 metres cubed. That's how much the volume of the cylinder is, 167.65 metres cubed. Now we know the final volume of the cylinder, we need to know the final volume of the fuel. So let's work out the expansion now, the expansion of the fuel. And that is, the expansion equals the cubical expansion times the temperature rise times the original volume. Now you put this in, you get 59.8 metres cubed. Okay, so that's quite a lot. That's expanded by 59.8 metres cubed. So the final volume of the fuel is 158.56 plus your 59.8 is 218.36 metres cubed of fuel. Now we know the final volume of the fuel. We know how much it's going to spill by looking at the volume of the fuel, look at the volume of the cylinder, basically 218.36 minus 167.65 is 50.71 metres cubed. Therefore, if the cylinder was involved in a fire and heated to 415 degrees C, then 50.71 metres of cubic metres of fuel will be spilled.